Finally, the very rare trajectory. This is 3i Atlas. This is Mars. 3i Atlas is about to swing by, and a fleet of camera-ready rovers and orbiters are standing by to snap some pictures.
The announcement hit the science world like a shock, because James Webb confirmed that 3i Atlas has changed its path in a way no normal object should. The new data shows a clear shift in its motion, and every model now points to the same outcome as the object moves toward Mars with growing speed. Researchers say this is no longer a simple comet passing through the solar system, and the event may become the most unusual moment modern astronomy has ever recorded. If the path is this direct, then what forced an interstellar traveler to move toward a planet? What happened at the start of its journey that made scientists watch it so closely? The discovery of 3i Atlas began in the mountains of Chile because the survey telescope system known as Atlas detected a strange object moving through the night sky on July 1, 2025. The topic became serious very quickly, since the early readings showed a speed that did not match any comet known in the outer solar system, and the path looked more like something entering from deep space. Scientists confirmed that its orbit was hyperbolic, which meant the object was not bound to the Sun, and this detail alone proved that the visitor did not come from any place we could call familiar. The first team that tracked it noticed how its movement cut through the sky at an angle that opposed the direction of the planets, and this unusual behavior made it clear that they were watching something that had been traveling for a very long time. The more the team observed the object, the more unusual it appeared, because the brightness remained steady even as it moved across different parts of the sky. Comets from the outer regions usually show changes when they warm under sunlight, but 3i Atlas kept a stable glow, and this raised new questions about its structure and the materials inside it. Researchers estimated its age at more than 8 billion years, which placed its birth long before the formation of our solar system, and this detail helped them understand that they were looking at a piece of ancient matter that had survived storms around another star. The idea that such an object had crossed the huge distances between stars gave the team a sense of wonder and caution, since even a small body moving at such a speed could have unpredictable effects on any world it passed. The early trajectory models showed that the object was not drifting in a random way, because the line it traced across space moved with a level of precision that made scientists watch it more closely. When they mapped its incoming angle, they found that it would cross the orbital plane of the planets almost exactly, and the chances of that happening by accident were very small. The object passed through the solar system as if it had followed a route shaped by long cosmic forces, and this picture made the scientific community pay attention to every new reading. 3i Atlas became the third interstellar object ever recorded, and this fact alone made the discovery historic, since only 2 others had been seen before, and neither had entered the system with such clarity. Each new night brought more data that confirmed the early findings, and the excitement grew as the object showed no signs of slowing down. The event turned into a global topic because the idea of seeing a visitor older than the planets raised questions about what kinds of systems could produce such bodies. It also made researchers wonder how many other travelers might be passing through without being noticed. If one object this old could enter the system so clearly, then how many more might be moving in the dark between the stars? What part of its strange path first revealed that something was truly wrong with the orbit of 3i Atlas? The strange orbit of 3i Atlas became clear once scientists mapped its early path, because the object moved in a direction that almost no natural body inside the solar system follows. The topic sentence explains the main shift, and the details show how each measurement pushed researchers toward the idea that something was not behaving normally. 3i Atlas traveled on a retrograde track, which meant it moved opposite the motion of the planets, and this rare pattern made the team examine the data with greater care. Most visitors from the outer regions follow long curves shaped by gravity, yet 3i Atlas cut across space as if it ignored the usual pull, and the slight angle of only 5 degrees from the orbital plane added to the mystery. When the first models connected these points, the object looked less like a wandering comet and more like a traveler entering the system with a path shaped long before it ever reached the Sun. The next detail that deepened the suspense was its extreme velocity, because the incoming speed was so high that sunlight barely affected its motion. Typical comets slow down slightly as they fall toward the center of the system, but 3i Atlas continued with almost no change, and this behavior suggested that the force guiding it came from outside the familiar environment. Engineers checked the readings many times to make sure nothing in the tracking software caused an error, yet each confirmation returned the same result. The object moved with a precision that seemed unlikely for something drifting for billions of years, and this steady course made scientists ask what kind of event could launch a body at such speed and still keep its direction nearly perfect. The early predictions grew more alarming when the projected line showed 3i Atlas moving close to Mars, because the orbit connected the object to a narrow region that few natural bodies ever cross. When researchers shifted the timeline forward, they saw how the path approached Mars with increasing certainty, and the chance of this being an accident dropped even more. The finding did not suggest intelligent control, yet it did show a level of order shaped by distant forces that no one fully understood. As more observatories joined the effort, the models continued to tighten, and the object's movement became the focus of nightly reports shared across laboratories worldwide. What made everything even more unsettling was the way the orbit held steady despite the different gravitational pulls from the planets, because even small influences normally cause drifting over time. 3i Atlas moved through these regions without losing its course, and this stability challenged ideas about how interstellar objects behave once they enter a new system. By the time James Webb confirmed the shift in direction, most experts agreed that the orbit did not match anything seen before, and the approach toward Mars looked deliberate only in the sense that natural forces alone could not explain the alignment. If the orbit was already this precise, what happened when 3i Atlas moved close enough for Mars to observe it directly? The close pass of 3i Atlas near Mars became one of the most important moments in modern astronomy, because it allowed scientists to watch an interstellar object at a distance that had never been possible before. The event happened on October 3, 2025, when the object moved only 0.19 astronomical units from the planet, and this distance placed it inside the range of several high-resolution instruments already orbiting Mars. The Mars Reconnaissance Orbiter and the MAVEN mission were both in ideal positions, and each spacecraft captured details that Earth-based telescopes could never reach. The topic sentence explains why this moment changed everything, and the examples show how quickly the scientific community realized the value of this pass. The MRO team focused on its powerful camera system, and the images revealed a clear coma around 3i Atlas as well as a faint trail of dust that stretched behind it. These features look different from ordinary comets inside the solar system, yet the camera still managed to record the shape with surprising clarity. The brightness around the object appeared smooth, and this helped researchers define the size of the gas cloud forming around the core. MAVEN observed the same approach through a different lens because it measured how charged particles moved around the object. The readings showed light shifts inside the plasma environment around Mars, and this suggested that material escaping from 3i Atlas interacted with the planet's thin upper atmosphere. The value of these observations became even greater because Earth could not see the same level of detail. Earth-based instruments had to deal with distance, atmospheric distortion, and limited viewing windows, yet the orbiters above Mars stayed locked on their target. The combination of two missions working at the same time gave researchers a rare set of measurements, and the precision helped them estimate how the object was shedding material as it moved across the inner system. This information allowed scientists to compare 3I Atlas with other comets, and the differences pushed them to question many ideas about the behavior of interstellar bodies. The next surprise came from the timing, because Mars was never expected to act as a natural observation platform for an interstellar visitor. The orbiters were designed for planet science, yet they suddenly played a new role that no one had predicted. Their instruments recorded every shift in the object's brightness as well as every change in its outline, and the combined data made it clear that 3I Atlas behaved in a way that did not match anything normally seen in the region. The event also proved that having active spacecraft around other planets could open new doors in astronomy, since they allowed the scientific world to watch unusual events from fresh angles. The experience left researchers with a new question, because the strange features seen near Mars suggested that the object carried more mysteries inside its core. If the behavior of 3I Atlas looked unusual in the images, then what would the chemistry reveal when the data was examined more closely? What hidden clues appeared in the material of 3I Atlas that made scientists rethink everything they knew about comets? The chemical signature of 3I Atlas became the next major surprise, because the spectroscopic data showed patterns that did not match the behavior of any comet normally seen inside the solar system. The topic sentence marks the shift in focus, and the details reveal how each measurement challenged earlier expectations. When researchers examined the gas surrounding the object, they found levels of carbon dioxide that were unusually high compared to water vapor, and this ratio did not fit the profile of comets formed near our own sun. Most comets release large amounts of water as they warm, yet 3I Atlas produced far more carbon dioxide, and this imbalance hinted at a place of origin far colder than any region familiar to planetary scientists. The dust grains offered another clue, because their reflective properties did not follow patterns seen in comets shaped by the solar wind. Instruments recorded particles that scattered light smoothly, and this effect suggested that the grains had a different internal structure. These particles also moved through the coma in a way that looked more stable than expected, and this meant the material inside 3I Atlas might have formed in a disk with different chemical rules or different pressure conditions. The idea that 3I Atlas grew inside a distant system with its own timeline gave researchers a new way to interpret the data, and each new reading strengthened the idea that this object carried a unique record of another star's ancient environment. Another detail came from the gas surrounding the nucleus, because the ratios between different molecules did not match the signatures of known comet groups. The pattern suggested that 3I Atlas formed beyond the outer boundaries of a protostellar disk, in a zone where carbon-based ices appeared before water crystals could develop. This placed the birth of the object in a region colder than the Kuiper Belt and far beyond the orbits of gas giants that would exist in other systems. The idea of studying such material inside the inner solar system felt almost unreal, and the event gave astronomers a chance to examine chemistry shaped by a history older than the planets. The unusual chemistry raised new questions about how interstellar bodies survived the long trip between stars, because the molecules inside 3I Atlas appeared stable despite radiation exposure. Some scientists suggested that the interior was denser than expected, and the compact structure allowed the object to shield its original material. Others believed that the object might have formed with a unique layering pattern that preserved the oldest molecules while allowing newer material to escape during heating. The fact that 3I Atlas showed such strong carbon dioxide release helped support the idea that the surface held the first clues about the environment where it began. The findings created excitement across different research groups because each detail pointed to the same idea. 3I Atlas did not behave like anything known in the solar system, and its unusual material forced scientists to rethink what comets could look like when they form around different stars. If the chemistry looked this strange, then what effect would these materials have once the object moved into a path that pointed directly toward Mars? If the chemical clues were already this unusual, what happened when scientists realized the orbit itself was changing in a way they could not explain? The most alarming moment in the study of 3I Atlas came when scientists realized that its orbit had begun to shift, because the new trajectory no longer followed the predictions shaped by classical celestial mechanics. The topic sentence introduces the turning point, and the details show how each new measurement pushed the scientific community toward the same uneasy conclusion. When 3I Atlas passed Mars, several observatories noticed a subtle change in its motion, and the angle of its path altered in a way that could not be explained by the planet's limited gravity. The adjustment was small, yet it became significant since it created a line that pointed more directly toward Mars than any earlier model had suggested. The James Webb Space Telescope confirmed this shift with high precision because its infrared instruments tracked the object across several observation windows. The change in vector showed that 3I Atlas had not simply continued on its earlier hyperbolic route, and the new shape of the orbit made it appear as if something had nudged the object. Scientists checked for a possible burst of material from the comet, yet no signs of such an event appeared in the data. They also searched for magnetic forces or solar wind disturbances that could influence the path, but nothing matched the strength needed to create the change. The lack of a clear cause made the situation more confusing, and soon the research teams proposed three main theories to explain the unexpected movement. The first theory suggested that 3I Atlas may have crossed a stream of energetic particles from an unknown source, and the impact of that stream acted like a force. The idea came from cases where solar storms had altered the path of small bodies, yet the measurements showed that the object experienced no major spike in radiation. The second theory proposed that the interior of 3I Atlas had a structure capable of reacting to sunlight in a unique way, and the release of gas from different layers could shift the orbit unevenly. This idea was based on the strange chemical readings seen earlier, and it helped explain why the object behaved differently from typical comets. The third theory was the most debated because it suggested that 3I Atlas might adjust its direction due to an internal mechanism not yet understood. This did not imply intelligence, yet it raised questions about natural processes that could produce such behavior inside a body older than the solar system. The important detail was that all three theories led to the same result, because the new orbit now targeted Mars with greater accuracy than before. The shift looked too deliberate to dismiss, and the calculations showed that the path narrowed toward a specific region of the planet's orbit. Experts warned that if the change continued, 3I Atlas would intersect Mars in a matter of weeks, and this possibility turned scientific curiosity into global concern. The event became the focus of nightly reports, and researchers updated the trajectory models every few hours to track the smallest changes. The sense of urgency grew as more data arrived, because the object showed no sign of drifting away from its new course. The system of checks and recalculations confirmed that the change was real, and this meant the event unfolding in the sky was unlike anything seen before. If the orbit had shifted this much after passing Mars once, what would happen now that the object was moving straight into the planet's path? If the new trajectory pointed directly toward Mars, what kind of impact could an interstellar object create when it finally struck a planetary surface? The potential impact of 3I Atlas on Mars raised new levels of urgency, because scientists understood that an interstellar object striking a planetary surface could create effects never seen before. The topic sentence introduces the scale of the event, and the details explore what might occur once the body enters the Martian atmosphere. Based on current estimates, the object may span a few dozen to a few hundred meters, and this size is large enough to release energy far greater than any recent impact recorded on Mars. As 3I Atlas approaches at high speed, the thin atmosphere would offer almost no resistance, and the body could reach the ground with most of its structure still intact. Researchers predict that the collision would produce a deep crater because the kinetic energy of an object traveling at interstellar velocity would carve a hole larger than typical meteoroid strikes. The shockwave would spread across the nearby region, and the plume of dust would rise high into the sky, carrying with it a mixture of Martian soil and material from another star system. This plume could be detected by orbiters, and the unique particles inside it would give scientists the first chance to examine alien material deposited directly on a planet. The event would also release heat intense enough to melt rock at the point of impact, creating a layer of glass-like minerals similar to those seen in past cosmic collisions. The orbiters around Mars could capture different parts of the event because each spacecraft carries instruments suited for specific measurements. Some devices could track plasma waves moving outward from the impact, while others could capture thermal signatures as the dust cooled. The shockwave might also reach sensors designed to measure atmospheric pressure, and these readings would help researchers understand how a thin atmosphere responds to extreme energy. The rovers on the surface might detect vibrations through the ground, and even a weak seismic signal could provide valuable information about the direction and strength of the impact. What makes the scenario even more remarkable is the chance to study ejecta that contains molecules formed around another star, because this material could stay on the ground for years. Future missions might collect samples from the crater, and those samples could reveal structures or isotopic patterns completely different from anything found in the solar system. The idea of reaching into another star's history through debris scattered across the Martian landscape has become one of the most exciting parts of the prediction. If the impact could deliver alien material to Mars, what might humanity learn from the aftermath once scientists begin studying the debris? The possible aftermath of a collision between 3I Atlas and Mars may give humanity one of the most valuable scientific opportunities in history, because the debris left behind could reveal how planets form in distant star systems. The topic sentence introduces this discovery potential, and the details explain how each part of the event could shape future missions. When the dust settles across the Martian surface, the ejecta will contain a blend of local minerals and particles shaped under conditions far beyond the solar system. Scientists believe this mixture could help them study chemical structures that formed billions of years ago, and the preserved particles may hold clues about temperature, pressure, and radiation levels around the comet's birthplace. Rovers and landers could play a major role once the ground becomes safe, because their instruments can detect small variations in composition and isotopic ratios. These readings help researchers compare Martian minerals with the alien material deposited after the collision, and this comparison may uncover features not seen in any sample collected so far. The idea that a rover could record the first direct trace of matter formed near another sun has already energized research teams across the world. Orbiters would continue to map the surface as the dust settles, and their sensors could identify impact regions where the concentration of unusual compounds is strongest. One of the most exciting possibilities involves the search for prebiotic chemistry, because the fragments from 3I Atlas might carry molecules created in environments far colder or more energetic than those in our system. Although no one expects biological life to survive interstellar travel, the presence of simple organic molecules could help scientists understand how widespread these building blocks may be in the galaxy. If certain patterns appear repeatedly in the samples, they could hint that the early conditions for life are not as rare as once believed. This would reshape the way humanity thinks about habitability and the formation of complex chemistry. The long-term benefit extends beyond chemistry, because the event could also refine models of planetary evolution. The layered ejecta would show how Mars reacts to high-energy impacts, and this information helps researchers predict how planets lose or retain their atmospheres. Each new measurement could challenge assumptions about the early solar system and about the forces that shaped rocky worlds. These ideas guide future missions, and the collision would become a reference point for decades of exploration. If the aftermath holds this much potential, how will the world respond when James Webb confirms that the object is truly locked on a collision course? James Webb has now confirmed the model that researchers feared most because every new calculation shows 3I Atlas moving on a direct path toward Mars. This moment marks a turning point in planetary science, and the short time left to observe the object makes the event even more intense. What happens next may reshape everything we know about impacts, alien material, and the history of distant stars. If this collision reveals answers we never expected, what questions will humanity dare to ask next? If you want more updates on this story, remember to like the video, share it with others, and subscribe for the latest discoveries.